In today's lesson, we're going to take a look at D7, frictional force, and to prepare us for that, we're going to do a review on gravitational and normal force, which we talked about in our last section. Just as a recap, gravitational force is the force with which gravity pulls it down to the Earth's surface and is determined by multiplying the mass of the object by acceleration due to gravity, which is 9.81 meters per second squared. And normal force is determined by determining how much force is acting between two surfaces. We looked at gravitational force. We're going to look a little bit more at normal force today. So to start this, we're going to do an example. In this example, we're going to determine the force of gravity that's acting on a 1.2 kilogram book that's resting on top of the table. Now, once we have that force of gravity, since the book is resting on the table must be supporting the book. We'll determine what normal force is acting between the table and the book. So let's first look at this gravitational force. When we're doing that, we'll list what we know about the problem. We know its mass, which is 1.2 kilograms, and we know the acceleration, which is due to gravity, is 9.81 meters per second squared, and that's acting in the downward direction towards the center of Earth. And we have to find what the force of gravity is initially. And to do that, we're going to use the equation force equals mass times acceleration, with acceleration in this case being acceleration due to gravity. And when we multiply the mass of the book, 1.2 kilograms, by the acceleration due to gravity, we find that it has a gravitational force of 11.8 newtons. Now, knowing this gravitational force, and knowing that the book is at rest on top of a table, means that the book must be in equilibrium. It must have zero net force. So if we look at this from a free body diagram perspective, which I put here on the right, you can see that the force of gravity pushing down on the book is 11.8 newtons. Now, between the book and the table, there's a contact force, a pressure between the two. The table must be exerting some force on the book, holding it up, in order to get that book to be stationary. That is the normal force. That's the force acting between two surfaces in contact. The gravitational force is pushing into the table with 11.8 newtons. The table must be pushing back on the book to keep it in equilibrium with an additional 11.8 newtons, but in the opposite direction. So when we are trying to find the normal force that the table is applying to the book, it's exactly the same as the gravitational force of the book, because that's what the table must withstand. So the normal force in this scenario is 11.8 newtons. This is the most common application for normal force, and the vast majority of the times that you're determining normal force in the class, you'll be determining it by finding the force of gravity. It's not the only kind, and it's not the only method we can use to find normal force, but it is the most common.